All right, so now we're going to look specifically at arithmetic sequences. And an arithmetic sequence, well, first off, remember a sequence is just a list of numbers. So 3, 6, 9, 12, 15 would be a list of numbers, but they have to have a pattern in them. If the pattern, as in this case, is adding or subtracting a constant value at each iteration, then we call it an arithmetic sequence. So in this case, the arithmetic sequence has a common difference denoted by the letter D of 3, because the difference between each term is a positive 3. Another example, 2, 0, minus 2, minus 4, minus 6. If I were to take the same steps, 2 take away 2 equals 0, and double check to make sure that the pattern holds all the way across the sequence. It does, so I can say that the common difference, D, equals negative 2. And in both cases, I can use the common difference to find the next few iterations, or the next few terms. So 15 plus 3 is 18, plus 3 is 21, plus 3 is 24, on and on and on. Or negative 6, take away 2, negative 8, take away 2 more, negative 10, take away 2 more, negative 12, on and on and on. So the common difference is a fundamental part of an arithmetic sequence and can be used to write both explicit and recursive formulas of an arithmetic sequence. So let's find both a recursive and an explicit formula for the nth term of a sequence containing the elements 4, 3, and negative 8. So first we want to determine whether it's arithmetic. So to go, if I wanted to move from 14 to 3, that would take subtracting 11. And if I subtract 11 from 3, indeed I get negative 8. So I can say at this stage of the game that I'm pretty sure that the common difference is negative 11. Let's take a couple more terms. Negative 8, take away 11, negative 19. Take away 11 more, negative 29, negative 30. And let's write these up and see if we can get at a formula for explicit formula and a recursive formula for this sequence. And we want the formula to use our common difference. So a sub 1 is 14, a sub 2 is 3, a sub 3 is negative 8, a sub 4 is negative 19, and a sub 5 is negative 30. And now let's look at how can we get to each. Remember, we're going now for an explicit formula, so how can I go from my first value to any value without having to go through the intermediate values? So let's break this down. 3 is equal to 14 plus the common difference, negative 11. So 14 take away 11 gives me the 3. Negative 8, if I start at 14, it's equal to 14 plus, well, I take away 11, but then I take away 11 again to get to the negative 8 from my first element. The next one, 14 plus, I take away negative 11, which takes me to 3. And then I take away another 11. I keep saying take away negative 11, but I add a negative 11, and then I add a negative 11, which takes me to negative 8. And then another negative 11 takes me to negative 19, and so on and so on. So if I rewrite this, I can rewrite it as 14 plus negative 11 times 1 to use a different parenthesis configuration. Then the next one, start with 14 plus negative 11 times 2. This would be 14 plus negative 11 times 1, 2, 3. This one would be 14 plus negative 11 times 4. And let's double check. Negative 11 times 4 is negative 44. 14 take away 44 equals negative 30. That works out. So I can say that the nth term for this sequence, the nth term is 14 plus the common difference, negative 11, times n minus 1. To get the fifth term, I multiply the common difference by 4. To get the fourth term, I multiply the common difference by 3. To get the third term, by 2. So I multiply by n minus 1 times the common difference. So now I just need to clean it up and make it pretty. So I have 14 minus 11n plus 11 and negative 11n plus 25. So for my example, the explicit formula would be a sub n equals negative 11n plus 25. But I've also honed in on a general formula. I can use the common difference to find an explicit formula for any arithmetic sequence. If I start with, so the nth term is the first term plus whatever the common difference is times the n minus 1 term. So I've arrived at a formula using the common difference and the first term to be able to write an explicit formula for an arithmetic sequence. Now let's figure out how to write a recursive formula for an arithmetic sequence. We'll go through the same process. A sub 1 equals 14, a sub 2 equals 3, a sub 3 equals negative 8, a sub 4 negative 19, and a sub 5 is negative 30. Now this time, remember, we only want to know what did I have to do to go from one element to the next. So from one term to the next, and then from that term to the next term, and that one to the next one. So it almost seems too trivial to even mention, but I'm going to mention it. To get from 14 to 3, I had to add negative 11. But then to get from 3, oh, hang on, I wrote that wrong. To get from 14 to 3, I had to add 14 plus negative 11. There we go. To go from 3 to negative 8, that's 3 plus negative 11. Because remember, I'm only going from one to the next, not from the beginning to wherever I want to jump. So to go from negative 8 to negative 19, that's just negative 8 plus negative 11. And so we can see quite easily that the formula is that a sub n equals a sub n minus 1, the previous number, plus negative 11. So the formula for the recursive, or the formula in the recursive form for a sub n, is the previous term, a sub n minus 1 minus 11. Or in more general terms, the formula a sub n minus 1 plus the common difference. So let's get in the pool and make our toes wet. Let's play around. Let's find the 41st term. Yikes. So we want to find a sub 41 of the arithmetic sequence 11, 4, negative 3, negative 10. Well, luckily they told us it was arithmetic, so I know I should be able to find a common difference. So from 11 to 4 is minus 7. From 4 to negative 3 is negative 7. From negative 3 to negative 10 is negative 7. So I know that my common difference equals negative 7. Okay, well, let's use one of these formulas. I have D and I have my first term. So why don't I go ahead and use this formula, the explicit formula. I have A sub 41 equals A sub 1 plus D times n minus 1. Okay, I mixed everything up here. Let's make it more clear. So A sub 1 is 11 plus D is my common difference, negative 7, times n minus 1. Well, I'm looking for n is 41, so I want to do that times 40. So that's 11 minus 7 times 4, 280. And so my 41st term should be negative 269. Cool. Okay, let's do another one. This time we want to find the first term of the sequence when we know that the 44th term equals 229, and we know that the common difference is 8. So I'm going to use the first formula again, but this time I like to solve my literal equations for what I'm looking for before I start to do my distributions. So, before I do my substitutions. So what I want is A sub 1. So if I solve for that, that's A sub 1 equals A sub n minus D times n minus 1. Just noticing that this is all one value once I plug in my numbers and simplify it. So I can just subtract it as a number. Now I can plug in my values. So A sub n is, A sub 44 is 229 minus D, which is 8. And so n minus 1 has to be 43. So through the magic of planning ahead, that's 115, or negative 115. So I know that the 44th term, given the initial information, is negative 115. And last but not least for today, sometimes we're actually asked to write a sequence, an arithmetic sequence, when we're given the first and last terms. So if I'm given the first term, 6.2, and the last term, negative 1.6, and I'm asked to write a sequence with 5 arithmetic means, which just means 5 terms. So I already have, or I should say actually, with 5 in between terms. So these would be arithmetic means, the terms here in between. So I have 1, 2, 3, 4, 5. So basically I'm looking to write a sequence where I can put in these values, and after I'm finished, I would be able to have some D value as the arithmetic. So again, I'm going to use the same formula. I'm going to notice that this is my first term, A sub 1, and this is my 1, 2, 3, 4, 5, 6, 7th term, A sub 7. I don't know what D is, but I can fill in everything but D and solve for D in my formula. So A sub n equals A sub 1 plus D times n minus 1. Well, if I know what n is, I can find n minus 1. A sub 1 I have, A sub n I have. D is the thing I'm actually looking for. So let's solve this function for D. So the first thing I have to do is subtract A sub 1 from both sides. So A sub n minus A sub 1, and then I'll divide by n minus 1. Now if I plug in values, A sub n is A sub 7, which is negative 1.6, minus the first, 6.2, divided by n, which is 7, minus 1, which is 6. So once again, with good planning, That's negative 1.3. So now I know that my common difference is to subtract 1.3 from each term. I can just do that and fill it in. So 6.2, take away 1.3 is 4.9. Take away 1.3 is 3.6. Take away 1.3, 2.3. Then I have 1 and negative 0.3. And so now I've created a sequence with the right number of means, that's terms in between the starting and last terms that were provided, and a common difference of negative 1.3.